Hey, Gene, this is Roger. Can you hear me?
Yes, I can, Roger.
Good morning. Good morning, Jonathan.
Good
I got
morning.
I got William in here.
Hi, Roger.
Okay. And what we're going to do, Roger, is we're going to have a question and answer period at the end. So
Okay.
during the course of the presentation, it would be helpful to make sure you mute yourself so that we
Okay.
don't hear any background noise. And then at the end, we will have a Q&A session.
Okay, beautiful. Thank you, sir.
You're welcome, and thank you for attending.
Yes, sir.
We're going to start in about 1 minute.
Right. And if anyone has any questions that occurred during, please wait till the end, but you could also type it into the chat so that we have a record of it and we can address the question during the Q&A session.
Yeah, yes. And I think I should probably mention that. Okay. All right. So I guess we're going to get ready to start. So I just want to, just for technical purposes, Jonathan Doan, Dr. Doan, who is with Nuvant System, is sort of monitoring or administering this webinar. So as he said, if there is a chat box on your screen and you can enter questions, and John will make sure that all the questions posed in the chat box will be answered. And that will be much better than verbally voicing them so that we can move through the webinar. So I think we're ready to start. And before we start, I want to thank Jill and I want to thank, EnoPro, Car for inviting Nuvant to present this. And we're very thankful for Jill's exposing her customers to us. We hope that we're going to be able to present to you solutions that will help you with your business. So I'm Eugene Smotkin. I'm the CEO and the at a high level at least I do all the electronic design. Just to give you a brief background, I'm a professor of electrochemistry at Northeastern University. Nuvant Systems is my spin-off company. Nuvant's been around for 20 years, and I've been doing electrochemistry for longer than that, in fact. And most of our work now at my university laboratories are related to the recovery of reversible losses in batteries and repurposing of batteries. And my companies are more focused on equipment and reconditioning systems. So today we're going to talk about the Nuvant system, which includes several pieces of equipment and a suite of software packages or algorithms, which combined together provide a system that we have made available. So to outline the Nuvant system, we're going to talk a little bit about module reconditioning and balancing. We're going to talk about state of health parameters and what parameters are important. Here's some feedback.
Hello, Gabriel, you need to mute yourself, please.
Yeah, if everyone can mute themselves. John, can you mute everyone? Because please make sure that you're muted, otherwise we'll get feedback. Okay, so someone's not.
1 second, I'll write down 1 second.
Okay, all right, good. Ross, I think. All right, John just came by and took care of that. Okay, by the way, we will, during the Q&A session, we will give everyone an opportunity to ask questions and we'll have discussions. But for now, I just muted everyone so that we can avoid the feedback. So as I was saying, we're going to talk about modules, state of health parameters. We're going to talk about how a library is developed. So you're actually going to have a library of modules, and you need to be able to easily find your modules that you need. Just very similar to someone who's in a gigantic library. They look up what they want in the you know, the librarian you know, search engine, and then you can easily find your inventory. We're going to go talk about automated module selection and sequencing so that you have balanced blocks. We will talk about a workflow schematic with some sample ROI calculations, and a little bit about how to minimize non-value added movement. One of the things you want to focus on is the reduction of non-value added movement in your production plant. So we'll have a little bit of overview on that, okay? So those are the topics that we'll be discussing. Just to let you know, our equipment, we started out selling EVC 30 units in the United States, and you can see that the United States is getting, you know, somewhat saturated with our equipment. We didn't sell anywhere other than the United States for years. We started in 2014 when we first designed the equipment. We actually have one out here in Hawaii, and now we're just starting to infiltrate internationally. So internationally, we have throughout Asia, we're entering Europe, Africa. We have about, maybe 20, between a few customers in Australia, we have over 20 units in Australia. We're now infiltrating throughout New Zealand as well. Over 300,000 modules have been reconditioned throughout all of our EVC users. Not all of the EVC users are flagged in this map. Some have requested that their outfits be confidential, but most of them are here. So we're in Singapore, Australia, Malaysia, and so forth, and growing. So we expect most of our future growth to be international, with some additional growth in the US as well. Our equipment, by the way, this manual that you see here is for our latest equipment, which is our EVD40, which is our automobile simulator. But just to let you know, all of our manuals now are available in English, Japanese, and Arabic. And our Russian manuals will be available shortly. And then if there's a demand, we can convert our manuals to any language. And we have professional translators on board. So all of the translations these are not automated translations. They're done very carefully, and they're reviewed by technical people to make sure that everything is accurate. So you don't need to worry about, even these presentations that we give can be given with our slides captioned in whatever language, okay? And these manuals will be made available through Jill at Enocar and Nuvant Systems. So what I want to mention a few things about, what are some of the advantages of the EVC30. And one thing to keep in mind is it's not just an instrument. There are multiple instruments. There are multiple packages that combine together to give us the system. But basically, what I want to point out is we will provide all the recipes you need for reconditioning. You don't have to develop them, although you can, and many of our customers develop their own because there are changes that are advisable if you're in an extremely hot climate, or maybe you have variations in the battery, variations in voltage. You also may decide to repurpose your batteries. And if you want to repurpose batteries, then your amp hour capacity parameters change. But anyway, the point is our equipment is customizable. It can be used to recondition NiCad batteries, nickel metal hydride batteries, not lithium ion batteries at this time, although we can recharge lithium ion batteries. We don't recondition them yet. Our equipment is research quality. We have a very high-speed data acquisition rate. We can acquire 16,000 points per second. And some companies do require that, and these are the people that are actually doing battery development work. So there are research organizations that use our equipment. Swatch watches, by the way, they use our equipment for development of new batteries, and those are not nickel metal hydride batteries. So the key parameters that we obtain for each and every module is its amp hour capacity, its watt hours or energy, its nominal voltage, or what we call average voltage throughout the whole charge discharge curve, and the internal resistance. So these four parameters are what we call state of health parameters. So the equipment will measure those, and it will actually archive those and will associate those with each module in your library. So all the data is maintained so that eventually when you get to the point of building battery packs, which we will discuss, you will be able to minimize the variance in the amp hour capacity. That is to say, to prepare balanced packs. Balancing is very important. This is the reason why when you buy batteries from Enocar, you don't buy individual modules, you buy balanced packs. If you try to buy a new module to insert into a pack that maybe had one bad module, that pack won't be balanced. But we will get into that in quite some detail. There are very often issues with the upfront capital costs of our EVC30, which you see here, but we have lower channel systems available. For example, in Serbia, their budget was limited, so we've sold people in Serbia and a few other places, and in Africa, we've sold as low as 10 channels. We believe that the sweet spot, if you want to go with lower channels and lower costs, is our EVC12. This happens to be a 10 channel, but the 12 channel is the most, as far as price per channel, it's more expensive than a 30 channel, but we believe that the sweet spot is the 30 channel or the EVC12, the 12 channel. So we make these available. So there are other options, and we also have a lease with option to buy options. That won't be the topic of discussion in this webinar, but in future studies that we can discuss that. So what kind of modules can we recondition? There are a variety of modules. There are modules such as the original Toyota, which you can see 1, 2, 3, 4, 5, 6 modules, 6 cells, I'm sorry. So 6 cells make up one Toyota prismatic module. 6 times 1.2 volts each is 7.2 volts. And Toyota rates at 6.5 amp hours, 6 cells. Some modules are larger. Here you see a 9.6 volts because it has 8 cells, 8.1.2. We can recondition this. We can recondition just about any size because we can upgrade the power supply in our EVC30 to handle any battery that you see on this monitor and even larger. We can recondition the Ford modules, Honda OEM modules. You see that the Ford Escape 1, 2, 3, 4, 5 only has 5. So because our recipe editor can enable you to input an infinite number of variations of parameters, any nickel metal hydride or NiCad battery can be reconditioned, including the Hondas and any Enocar battery. They have Enocars are even higher voltage batteries, I believe, and it's just a matter of getting the right harness. These can be reconditioned, they can be inventoried, and they can then be incorporated into a balanced way to build a battery. Okay. So the Nuvant system is not an instrument. It's not simply an instrument. The system involves two major pieces, equipment types, and 3 different software algorithms. So we have the EV charge, which controls the EVC30 or the EVC12, whatever you buy. We've sold units as big as EVC 120s. I think that's excessive, but EVC 30s can do the job nicely. So the EV charge is the one that will control the instrument, recondition the battery, fully customizable cycling, state of health. And then what the EVC 30 also does is it takes all of the data for each and every module, and it makes that data available as a summary file that can be exported to the pack builder. And the pack builder basically keeps track of your inventory. And what it does is that it keeps track of your inventory using either the QR codes, you can use a QR code reader, or you can assign a number, which is called the inventory number. And then you have something equivalent to something similar to like the DUI, the library management systems that are available. So basically the EVC30 outputs a summary file. So every single module on your shelf is archived with a full set of data, okay? And what the pack builder will do is it will sort modules by their state of health parameters, and it will also select the module. So when you want to build a pack, the pack builder will tell you which modules on the shelf to get, and it will even tell you which modules to pair together to form blocks and the sequence in which you want to incorporate them into your module assembly, which will eventually be buttoned up into a full battery when it is included in the enclosure. Once you've completed a battery, or even before your module assembly, some people, we had customers that would put these batteries in a vehicle and drive them around. That's not a practical solution. If you have inclement weather, snow or hurricane, you're not likely going to be driving vehicles around. And it's also very difficult to drive vehicles around in a reproducible way. And so now what we've done is we've built a power tester, which is a 10,000 watt battery discharge unit. It allows you to discharge at up to 40 amps to do that final test to find weak modules, as you see a curve here for a weak module. This is just a high-level overview of the system, which is the EV Charge instrument, the EV Charge software, the pack builder software, the power test equipment, and the power test data output, all combined to give you a system which eventually ends up yielding, demanding a floor plan. Okay, so the next slide is an example of what the EVC30 does. So when you get a core battery, from your customer, because when you buy your Eno car batteries and you install your Eno car battery, you are going to get a core back from the customer. And if you look at the discharge curve of all of the modules, this I believe is probably a Prius. You can discharge and you see that they have different amp hour capacity. You see, they're actually dropping off in voltage at different times. And actually, if you take the time multiplied by the current, you have the amp hours. And so you have different amp hour capacities. So this is what we call an unbalanced pack. You have uneven discharge profiles. Also you see a large variation in the internal resistances, okay? So these are things that and actually as you discharge, you can see some of the internal resistances go wild, okay? So our equipment will take these systems through a profile, a charge-discharge profile, and after a series of cycles, you end up with what you see in the aftermath, okay? So afterwards, you see the consequence of a deep discharge and an analysis cycle. So what our system does is it takes it through a series of deep discharges, not fully charging the battery ever. And then at the end, we will fully charge the battery, take it through an analysis cycle to get all of the state of health parameters and measurement of all the internal resistances, and then be ready for generation of the data files to be exported to the pack builder. So this is the same battery pack. This was the core as received. This is after we processed it with our EVC 30. You'll see that it's much more balanced, not adequately balanced, but fairly well balanced. And you no longer see these wild variations in internal resistance values. Now, so what actually is going on with reconditioning? So I want to talk to you now briefly about what we refer to as reversible failure modes. Some battery failure modes are reversible and some are irreversible. If your battery's been overheated and it's vented and it actually has suffered a mass loss, we'll be teaching people who buy our equipment a lot more about mass loss, how to measure it. You can actually exclude batteries just by weighing them, in fact, if you do it properly. But some losses are irreversible. Nothing our equipment can do about that. But most of the losses and capacities are memory effect. They are actually reversible. And this applies not only to nickel metal hydride batteries for hybrid vehicles, but it also applies to all NiCad batteries. So if you have forklift users or or heavy equipment users that are still on NiCad batteries, you can, all of what I discuss in this presentation applies to the NiCad batteries. This presentation does not apply to lithium ion batteries. So let me tell you about normal operation. So if you have normal operation, you have a battery that can be charged, and we can sort of show it sort of schematically here with this blue region. The issue with hybrid vehicles is typically hybrid vehicles undergo a very shallow depth of discharge, meaning that the hybrid battery is primarily needed for regenerative braking to uptake power, to start up from a red light, to start up from a stall. And the hybrid vehicle has a internal combustion engine, and that internal combustion engine actually drives the car, and the battery is used for power assist. And so you don't want to discharge a hybrid vehicle battery heavily during vehicle operation. So a vehicle would typically discharge approximately 10% of its capacity. But what happens is when you have years of use, where you're only charging and discharging 10%, that remainder of unused material, and we sort of schematically show it with this black region that grows, undergoes a phase change. And what we're talking about when we say this phase change, we're primarily talking about the positive electrode. Memory effects are primarily at the positive nickel oxyhydroxide electrode of the battery, okay? And the reason why we know this is memory effects were first discovered in the NiCad battery. And the NiCad battery had a cadmium negative electrode. When they replaced the cadmium negative electrode with metal hydride, the memory effects were still there. And that's how we were able to determine that the memory effects are primarily the positive electrode side. And interestingly, the NiCad battery and the nickel metal hydride battery have exactly the same positive electrode. And that is the reason why our equipment works perfectly on NiCad batteries as well as nickel metal hydride. So basically, as you cycle through plus or minus 10%, this unused nickel oxyhydroxide develops crystals. There's actually a grain boundary that forms, or sort of a boundary between that which is used and that which is unused. And so you basically lose capacity. And that loss of capacity has a major effect on regenerative braking and the overall driving of the vehicle. So what reconditioning actually does is it breaks that barrier that you have through a series of deep discharges, charged discharges at very low voltages at high current. If you're at high current, you can bring a module voltage very low. You can bring them down to a few tenths of an amp. That happens all the time in vehicles that use, say, lithium-ion batteries. For example, in the Formula One racing, where they allow battery surge. At high current, you can have high voltage drop-off. So you do, what the instrument does is it does a series of charge-discharge cycles at some cutoff voltage, which we don't need to discuss here. And then once it's done with the reconditioning process, which restores all your amp hour capacity, you see all the crystallization is removed, then it does a state of health parameter analysis at 3.25 amps. And after it does that, it brings the battery to it can bring the battery to a finishing state of charge. And that's sort of what you can do with a battery, isolate. You want to take a battery, recondition it, and put it back into a vehicle. This is what you would do. We wouldn't recommend that. We recommend that you go through the workflow we're going to discuss, in which every module you recondition ends up in an inventory. And then you allow the pack builder to reintegrate modules into balanced batteries. And I will go over that in quite some detail in the slides that are coming up. But the main idea of this slide is just to show you that memory effects occur because of the shallow depth of discharging. And what we can do is recover that nickel oxyhydroxide capacity by a series of deep charge discharges followed by a state of health parameter measurement, which then gets exported to the pack builder into your library. So I mentioned to you that we do the analysis at 3.25 because this is the spec sheet that's made. This is a Panasonic spec sheet, and you'll see that their amp hour capacity, 6.5 amperes, was actually measured at 3.25 amp. So in order to be consistent, it's very important that we do our state of health analysis at 3.25 amp. And that in fact is what we do, so that these other terminologies that some may be familiar with and some not, such as C rate and rated amp hour capacities, will all be consistent. So this presentation is both applicable to those that develop brand new batteries and those that just want to recondition. So this is sort of a spec sheet that we pulled down from EVB Technologies. I don't think they exist anymore, but these are the same specs that Toyota had output for their prismatic batteries. But I only mentioned this to say that this is the reason why we do our analysis run at 3.25 amps. So when the left side shows an example of reconditioned data. So everything, all of the discharge curves will be a bit tightly more packed. And the export summary file will include everything you see on the right here, okay? It includes the amp hour capacity, the watt hour capacity, the average voltage, the internal resistance, and the QR code. That is to say, when you hook our equipment up to the EVC30, you can QR code those batteries so that it associates a QR code with the data. But more importantly, right, the QR codes are very inconvenient to work with. You can see over here, here's the reconditioning data. Every module is extremely well archived, right down to the point where we know what instrument actually reconditioned it, because you have the DAC card serial number. We know what instrument yielded this data. We know what channel it came off. We even know indirectly who the user that operated the instrument, the date, the factory date of the instrument, everything. And so we know that way if an instrument malfunctions, which is a rarity, but can happen, you can actually go trace back to your library and find out who used it, when, and what. So the channel number of the instrument, the actual instrument, and the DAC card number, its amp hour capacity, watt hour, its calculated voltage, which is done by integrating this area. All of this is very scientifically done. And the internal resistance for every single module is archived. And you can associate the QR code with your own library inventory numbering system. For example, everyone can be given, you can use your own inventory system because you're never going to have more than 5,000 batteries, or I'm sorry, 5,000 modules in your library. I'll show you examples of libraries. But once you have an inventory number associated with all the data, when the pack builder says you need the following 28 and here are the inventory numbers, you can go and pull them from the library and build your balanced pack. So from the EVC30, state of health parameters are exported to a summary file, which is used by the pack builder to build your battery pack that will then subsequently be tested by the power tester, which we will get to shortly. So, so what I'm going to do now is focus on what the pack builder actually does with the summary files, okay? So once you have the summary file, this summary file goes on. I mean, here are the top, the summary file actually orders them by amp hour capacity. So in this particular library, the highest amp hour capacity is 5.61. And by the way, there are no Toyota batteries with a 6 amp hour with a capacity that's, let me just move up a bit. You see the 6.5 amp hours? Okay. The reality is that at 3.25 amps, a brand new one can have that, right? But if you're operating at C1, for example, at 6 amps, no battery has a 6.5 amp hour capacity under normal usage. But that is the maximum using an analysis limited to 3.25 amps. Clearly the battery can operate at 20 amps, 30 amps in an operating vehicle. But those are the standards. So as I was saying, the summary file gets exported, and this sheet shows you what the pack builder does. Oh, just to make sure I got distracted. The summary file of your entire library starts with the highest amp hour capacity down to the lowest. There might be 1,000 modules in this library, and it will sort them all in order, okay? Now, when you want to build a battery, it's going to first cluster together modules that have a tight mean value or average value of amp hour capacity. You cannot just take the top, say, 28 modules to build a pack. And now, so this summary file is different from what you're going to see on the next slide, right? This is sort of the library data. Now, when you use the pack builder, it generates this output. And now what it has done is, first of all, this is another library. It has sorted the batteries, and there are 3 different kinds of packs that are shown here. The red bracket is for a Prius C. The green bracket is for a Prius. The blue bracket is for a Camry. And so what the pack builder is doing here is it's saying that if you want to build, let's focus on the Prius C or the red bracket, okay? It's saying that if you take the top 20 modules, okay, from your library, and I mean the top 20 in terms of amp hour capacity, you will end up with a battery pack that has an average value of, for some reason, my, I have something, I gotta move, okay, here we go. Okay, so you will end up with a battery pack that has a variance or a width or an error range of 1.3%, okay? We believe that's too high, but what the pack builder is saying is that if you wanna build this Prius C with your top 20 modules, you're gonna have a variance of 1.3%. Now, what variance is acceptable to you? I'm on a call, I'm on a conference call right now. Sorry for the interruption. Okay, so if you have a large library, then you can demand a small standard deviation or a small variance in your pack. If you have a very small library, your variances are going to be larger. So you'll learn and adjust and determine what works for you. But let me put it this way: the smaller your variance, the longer the lifetime of the battery. The smaller the variance, you could say the better balanced the pack is. So what this is saying is, if you take the first 20 modules in your library, you'll have 1.3%. If you scroll down to the next one, 1.3. If you keep scrolling down, eventually you can get down as low as 0.9%. And that's actually with an amp hour capacity of 5.88, which is not bad, okay? So basically, depending on what you want to demand, it's just taking them and it's taking the highest one up and calculating. So you probably would not use these 28, which are designated by this inventory number. You probably would want to go down to maybe 1%, okay, which is here, and start with 5.89. And if you do this and you keep choosing 1%, you will accumulate these high quality pack or modules, and those high quality modules can later be used to build your super packs or your very high quality batteries, okay? And the same goes for the Prius and the Camrys. You see, actually, if you look at the Camry packs, because they have 34, there are many more modules, you see the variance is 2.2%. Meaning that these high value modules are not good modules to put in a pack because they're too good. And the point is, this is the reason why you don't buy new modules to fix a bad pack. Because if you take a high amp hour capacity battery module, if you take a high amp hour capacity module and you put it into a set that has a mean value of, say, 5 amp hours, and there's nothing wrong with that, then your blocks are going to have a high voltage variance, and the Toyota is going to give you an error warning. That's the reason why if someone has a used pack and their mean value of their amp hour capacity is 5 amp hours, and there's nothing wrong with 5 amp hours, but they had one that had 3 amp hours, and they take it out, they put a new module in, a brand new module, that pack is going to fail. It's about teamwork, right? It's like if you have a canoe race, all of the paddlers must paddle in unison. And it doesn't do you any good to have 5 paddlers that are intermediate and then put a champion Olympic paddler in there. It doesn't help the team. So this is all about module teamwork. It's not about the best module. It's about the lowest standard deviation. And in order to get that, you need a system, not just an instrument, but a system, a library, and a data handler. And so this pack builder will give you the options. It will list the standard deviation. 2.2% is too high. What you would do in this case is you would move down to maybe 1% or maybe 1.3. You see, you would move down or further down. And all of these high-end, high-value amp hours, don't worry, you'll use them. But you'll use them when the standard deviation is tight. And that's how you're going to have good warranty management. Okay, so that's sort of the key behind the pack builder, which is a separate package from the EVC30, but it comes with the EVC30. Okay, so the EVC30 will give you the EVC30 software. It will give you the pack builder, which will tell you what modules to pull off your inventory. So the next slide, okay, for some reason my, I seem to be unable. Okay, here we go. Everything's good. All right. So once the pack builder selects your 28 modules based on amp hour capacity, okay? The next thing you need to do is, once you've selected the modules from your pack builder, you need to build the blocks. Now, the idea behind building a block, and the block configuration can vary, right? You have different car batteries, the block configurations are different. But whatever your blocks are, you want to make sure that you minimize the differences between the block voltages, because failure in a vehicle is all about measured differences in block voltages. So once you've selected, and the pack builder will give you the inventory number of your 34 modules, okay? What it will then do is it will match the highest voltage. Here you see 17 blocks that were made from 34 modules. And you'll notice that in this particular selection, which is actually the real data we have pulled from the above, the maximum block voltage difference is 75 millivolts. That is a very tight block voltage variance. It's like a new battery. How did we attain such small block voltage differences? It's because once you order all the batteries by amp hour capacities, you then reorder them, the selected ones, by voltage, and each block consists of matching the highest voltage module with the lowest voltage. You take the highest and the lowest, the next highest and the lowest, the next highest and the lowest, and that sort of maximizes the selection by, well, it maximizes the balancing. So by taking high, low, high, low, high, low, you not only have a good mean value, which was already pre-selected from the other ordering that you got, but you actually minimize variances by taking combinations of high, low for each block. So now you have a module assembly here with your desired standard deviation of the amp hour capacity. And once that is done, the minimal block voltage variance. So the pack builder tells you which, in fact, you can see here, block 1, you can see the 2 inventory numbers. These are the 2 modules, module 647, module 129, module 659. So you see, nothing is left to the user. This system, combined system, Recondition, it balances, it tells you where to go in your library and where to go and how to order them and place them into your enclosure. And any battery, your car batteries will fit into the current existing enclosures, because they're selling actually conversion kits. So the pack builder does all the thinking for you, okay? Now, the next thing I wanna mention is the new instrument that we just built, which actually has a multitude of applications. Our end users are finding more and more uses for these, okay? This is a very sophisticated piece of equipment. As a matter of fact, it's really a full battery analysis system. Once once you have actually once you've actually assembled all the modules, there are some end users that used to put the pack in a vehicle and drive around. Because sometimes, even though you've done everything right, some of the failure modes of some modules only appear at high current. And so now we have a power tester that you can plug the entire module, and we have a special harness that's not a normal commercial harness. We have specially made harnesses that will check up to 40 modules for you. And what this does is it will discharge your battery at 10,000 watt and 40 amps. And you can use this to power test your battery pack. In fact, you can charge, discharge, charge, discharge. In other words, if you can't afford to buy an EVC 30, you know, I wouldn't recommend it, but you could get away with working with this EVD40. We do not recommend that. We recommend using the EVD40 as planned, which is for power testing. However, the system has other capabilities that you might be interested in. This bullet here. This has a very sophisticated Sorensen power supply integrated with a high power resistor and cooling unit. This system can charge, for you people that are battery experts and battery developers, this system can charge by CCCC, constant current, which is for nickel metal hydride batteries, NiCad batteries, but it will also charge batteries by CCCV, which is called a constant current, constant voltage technique. Meaning, if someone comes to you with for example, a Nissan Leaf battery, or if they come to you with a Tesla battery, and they've unfortunately gone on vacation in Europe for 6 months, their batteries discharge, and now they can't start their car. You can charge any kind of battery up to 600 volt with this discharge charge unit. So we developed this in a very forward-thinking manner. That is to say, when we get to the point of reconditioning lithium-ion batteries, you will not need to buy a new power tester. And if you have customers with lithium-ion batteries that simply need to get their battery recharged so that it can work, so you can get out of the failure mode, this unit will recharge the Nissan Leaf battery, any plug-in battery, you can recharge it with this. But the reason we built this unit for is to simulate the vehicle for a final quality control of your balanced battery before installation or before buttoning up into the enclosure. So this is an example of the data. Here you see that this data acquisition with the power tester all took place in 8 seconds, okay? This is a 34 module device. This is happening from start. You can move these cursors around, right? These cursors can be moved so you can decide where you want your output. So you people that are OEM battery manufacturers, you can use this to analyze, and you can archive data at any start or end point. We recommend that if you're going to do a power test, we would recommend running the power test for about a minute, but even at 7 seconds, you're going to find the bad modules. Here you see 2, the purple one, and here you see a self-discharge, it's reverse polarized, 2 really bad ones. These 2 modules need to come out. So you need to pull them, use the pack builder, once you pull these, your inventory will be aware you pulled it. The pack builder will tell you where to get 2 modules that are balanced, and you can avoid finding this out the hard way. We've had people, they did everything right, they put it in the vehicle, it comes back. These returns have tremendously diminished. We have users in our New York facilities, our California facilities, and about that are using this, and their failure rates have diminished even further. So the power tester is a very valuable addition to our portfolio of equipment and software that we call the Nuvant system. Okay, so this is a facility that we have in New York. It's an early stage system that we assembled for a cab company in New York that has access to about 2,000 cabs. Basically, they service almost all of the cabs of New York City. And what you see in this particular setup is, in this figure, you see 1, 2, 3, 4 EVC 30s. This unit that you see here is actually an EVC 120. This is actually a 120 channel EVC unit. Here's their 4 EVC 30 units, and they actually see an EVC 12. But you want to pay close attention to the flaws in this floor design. This, we only recently started putting down, designs, but you'll see inventory, right? If you see this mess in the back, you see that? We're going to show you how to clean up this floor plan, but those are valuable. Those are empty enclosures. You're going to need those when you buy your car batteries, because the car batteries will fit in those empty enclosures. So you have a variety of inventories. You're going to have an inventory of enclosures that you're going to refurbish. You're going to have an inventory of raw cores, which end up on the EVC 30s or the 120. Here you see another view, EVC 120. Here are some finished units that are going on. This is a company that actually realized the ROIs that I'm going to show you momentarily. And here's that same facility. See here, all the packs lining up, building up inventory, new inventories of cores are coming in. Here's the same facility. You see a little messy. You see a couple inventories. Now you have your library. This is your module inventory, your inventory of enclosures. Here's your packs ready to go into an EV40. Someone just came online. Please mute yourself so that we don't get the feedback. Okay, so this is the facility there in New York, and I want to move down to the next one. Here's their library that they have. Now we're sort of cleaning up. We're learning. Okay, we're learning as we go along. They're getting ready to organize their enclosures. We're going to refurbish them. Here's the batteries ready for sale. And so little by little, the floor plan is evolving. This is not a floor plan. This is sort of the learning process. And I'll show you how a floor plan is designed, okay? So then we go, here is the workflow. And the workflow kind of lets you know, it's kind of a guide to how a floor plan would be designed, okay? So let me just move something out of the way. Okay, so let me describe how the workflow actually works. The first thing you want to notice is that you see 3 green blocks. 1, 2, 3. So your floor plan needs to be able to accommodate 3 inventories, right? So the way it works is a vehicle comes, you can start anywhere. You can start anywhere in the workflow. So let's say you have a battery pack inventory. So let's say, for example, maybe your battery pack inventory is a consequence of buying car batteries, or this company happens to be Thornalp. That isn't the point, like where they came from. You have batteries. So in this particular case, let's say car batteries. they can be installed into an enclosure. So once you have your inventory, a vehicle comes into your shop, you install the battery into the vehicle. So when you make that installation, you're actually going to get the core, okay, back from this. So you're going to install in the vehicle's going to drive away. But you're going to end up with its core, the core from that vehicle. That core gets split into a refurbish, that's that pile you saw. That core will be broken into enclosures that you need to refurbish. Maybe you want a nickel plate your bus bars or do whatever you want. You want to check to make sure the fan works, clean the filters, clean up the enclosures. And then the enclosures go here, and the modules go into the module inventory. So now you have, so here you have the vehicle comes out, you pull the core, you have a core inventory. When you take your core inventory and you break it out, you're going to end up with a module inventory, a core inventory, and you're going to end up with a battery pack inventory. So basically, you install in the vehicle, you're going to end up with a core. The enclosures go for refurbishment. The core modules end up on the EVC reconditioner. When the modules come off the reconditioner, they don't go into a vehicle. They go into a module inventory, and you know the state of health of every one of those. From the module inventory, you use the pack builder. The pack builder selects the modules, and they will end up in your module assembly that you're hoping to install in a vehicle. Most of these will make it into the vehicle, but nevertheless, to be safe, you'll put them on the EVD40 before you even put it in an enclosure, right? The EVD40 is going to evaluate every single module at 40 amp or 10,000 watt. Maybe you're going to find one or two failures. Usually not, but it will happen. Then you got to go back, pull those bad modules, readjust your inventory, find out where two best modules to replace that until this cycle is done. Now you're ready to button up, put it inside your enclosure, and from your enclosure, you go into your inventory. Now you have your battery packs that are ready for sale on the shelf, waiting for the vehicle to show up. When the vehicle shows up, you install the new battery or the refurbished battery. You get your core back from them. The enclosure gets refurbished. The core goes to the EVC30 into your inventory. So eventually you have three key inventories: your module inventory, your battery packs ready for sale, and your core inventory. Now the interesting thing is that this EVD can output the full battery voltage. This EVD can output up to 600 volts. There is no hybrid battery that is at that voltage. What that basically means is we can build a cable for you to connect this unit, the EVD, up to a whole inventory of batteries and hold them all at that intermediate state voltage that you need so that you can prevent self-discharge from becoming an issue. That's what this EVD can do, as well as power test. Now, and so on the other hand, if your batteries do self-discharge, the data is still good. You just need to take them, put them back on the EVD, and charge to the proper final voltage that you wish, which is probably 60 to 70%, stay at full charge, you're ready to go into the vehicle. So your floor plan, the idea behind a floor plan is that you want to minimize non-value added movement. Non-value added movement can be fatal to a large business. So you want to position the tables, the module inventory, the battery pack inventory, the core inventory, how you line these up, where you put the roller tables, etc., is all part of floor plan. We're not going to show you if individuals want a floor plan, it can be provided by Nuvant. Nuvant is developing a system of distributors. We're still working on that. Right now, we're so thankful to be working with Enocar, and you can see right where the Enocar battery fits. And when you put the Enocar back, and I'm only, or any type of battery, but when you take a battery and it falls into the cycle, eventually all nickel metal hydride batteries, it doesn't matter whether it's Enocar, Hunan, or whoever, or Toyota, all of them will eventually need to be reconditioned. So all of them will find their way into this circular loop, okay? And so the circular loop requires not just the equipment, but the pack builder, the EVD, the whole library development. People hire professional librarians to set up libraries that work so that when you go to a library, you can find a book in a pack of 1 million books immediately. You can walk right to the book. And that's what workflow is all about. That's what non-value added movement, the elimination of that, is all about. Is good floor plan. So eventually batteries will reject. Not every module, some modules will have irreversible losses. Those modules will go to your recycler. When you have a failure here, if you see a failure here, you have to go back to repick, that'll end up in the recycler. So you need to have a place to store your recycled batteries, your reconditioned, your module inventory, your battery pack inventory, and even your refurbished enclosures. So there's a lot of storage that's actually needed, and it can be well-tuned. This can be developed into a well-tuned. If you're a very small unit and you're selling 10 batteries a month, you don't need to worry about non-value added movement. But if you're a big outfit and you want to sell 1,500 or 10,000 batteries a year, you really want to pay attention to how this workflow can provide guidance to how you build your floor plan. You don't need Nuvant to design a floor plan. Nuvant can do it, Nuvant's distributors can do it, but there's a whole science behind floor plan and manufacturing science. And some of you customers that are looking at this probably know more about floor plan development than I do, but we know how to do this. So what I want to show you next is, sometimes there's a delay, hold on. I'm working on getting to the next slide, just a moment. Okay, just a moment. It's sort of similar before, I think it's because it's a big file. Let me see what we're doing here. Hey, John, you might want to come over here, just in case.
I'll come down. If you hit page down, I'll come over.
Okay, come on down. Let me just see if I can, I think what it's doing, it's sort of catching up. Just give it a second. Hey, John, I seem to be stuck on this slide. Oh, okay. Page down. Oh, okay. All right. I thought. So to give you a high-level understanding of ROI, okay? And I'm actually going to explain this, as some of this is going to appear very cryptic, okay? Now, first of all, just to let you know, you see this selling price? That's not the Enocar selling price for a battery. That's actually the MSRP. In other words, this would be your selling. And I just put this as an example, supposing you're selling at 1,900. So you may have bought Enocar batteries, you have new batteries, and maybe you're going to sell, but you can adjust these values, okay? This is a spreadsheet, okay? So let's say you want to sell 30 batteries per month. If you want to sell 30 batteries per month, then that is 360 batteries per year. Okay? Now, if you sell 30 batteries per month, you will be collecting core from those customers. That's the freebie that you get. What this is all about, this webinar is about how to value add to Enocar batteries. That is to say, you buy an Enocar battery, you're going to get a core back. And if you can do something with that core, starting with something that gives you a very good warranty management, then you've really gained value added to the battery. So what the point I want to make here is that if you want to sell 30 batteries a month, which is 360 packs per year, you only need to buy 91 batteries from Enocar. Because if you buy 91 batteries from Enocar, you're going to sell 360 batteries, right? Buying only 91 batteries. But you selected 30, that means 360. You need to assume a module return rate. A module return rate of 75%, I think, is a little ambitious. I can't reveal the source of the information, but major companies that sell reconditioned batteries have reported to me that a realistic return percentage is 67%. I'm going to show you precisely what I'm talking about shortly, okay? Shortly. But if you were to actually sell every battery at 1,900, right, including delivery, then you will sell 269 reconditioned batteries at a lower price. So here's your price of maybe, say, the Enocar batteries. They're going to be higher than your Recon batteries because they're brand new and they have a warranty. You have your Recon. Let's say you sold the new batteries at 19, the Recon at 13. Once you determine how many you want to process per year, right, then that defines how many EVC 30s you need. An EVC 30 can do up to 900 modules per month if you work 7 days a week. Realistically, it's more like 750 hours. But this is realistically, right? If you want to do that many batteries, you need only two EVC 30s and one EVD 40. So if you price the hardware pricing out, EVD 30, EVD 40, total cost of equipment, we'll let you give us a down payment and pay monthly if you want, 2-year contract, 5% interest. Your ROI, if you actually sold that many batteries, okay, then you could look at what your gross revenue is, the labor, which we estimated our labor costs, you can put your own in. Your return gross profit is very large with an ROI of 3.3 months. That's 3.3 months, that is to say, to recover all of the costs of the equipment. 3.3 months to ROI it, then the rest of it is all icing on the cake for a large gross profit. Realistically, if you're going to do an ROI, you should include the batteries that you buy. So if you want to include the batteries you had to buy, the ROI grows to about 8 months. But after that, you're home free and it's total gross profit. And your ROI is only the batteries that at that point, which is on the order initially, say 91, on the order of the equipment price, okay? So now the question is, where does this come from? If you want to sell 30 batteries a month, then that's 360 per year. You need to buy 91 batteries, and then your workflow will go. If you buy 91 batteries, you're going to sell 91 Enocar batteries, and you're going to sell 269 Recon batteries or Recondition. So to see this, I want to shift to an Excel spreadsheet. So I hope I can do this. Here is the Excel spreadsheet. So the idea behind this this is just sort of a calculator so that you can understand how the circular economics works, okay? Now, so this is a calculator that we built. Let's say you buy 150 car batteries, okay? Now, you put in a return rate, because your return rate, if you're actually selling car batteries, your module return rate is going to be pretty high because you're actually getting your cores from vehicles that are working, they're operating. So your return rate could be 75%. Now, if you're buying your cores from a wrecking yard, it's risky. You can buy a whole inventory of cores, they could be 30% return. So once you've bought them and you've figured out what your return is, because you've put them all through the EVC 30 units, you can put in the real value and see, what a disaster you've made by buying for an unreliable core provider. Now, buying from core providers is a good idea. You just need to quality control the purchase. What I'm going to tell you is you don't want to use a calculator like this with a return rate of over 75% because it's not realistic. If you sell 100 car batteries, you're not going to get 150 Recon batteries back. So you can adjust this percentage. Look at these numbers, right? If it's 75%, the return rate goes up. But the idea here is this. If you buy 150 car batteries, you're going to get 150 core back. If the return rate is 75%, you're going to get 112 batteries out of those 150 core. And if that's 75%, you'll get 84, 63, until finally it burns down to 1, and then you're done. And if you sum these up, that comes to a total of 597 batteries. Meaning, if you buy 150 batteries, you're going to sell 597 combination of car and also Recon batteries. I believe that is overly optimistic because, as I said, even the major dealers, like a major dealer in the United States, much larger than Nuvant, that we're collaborating with, they say 67%. So if you buy 150, it's very realistic, if you follow the system rigorously, that you're going to move 150 new batteries and about 300 Recon batteries. And that's the value added. That's how you optimize the value, okay? So this is to give you an idea of what you have to take into consideration when you do your ROI. And I recommend that anyone that wants to do ROI calculations, you should get your own business group to do it because that we assumed a selling price that makes sense in the United States. Our labor costs in the US are much higher. So our labor costs go into this. We basically have total cost of equipment. There are labor costs which vary enormously. But this sort of gives you an idea, a high-level approach to how you can think about ROI. I do not recommend taking this and putting it in a business plan. Use this as a model. Develop your own ROI because there's a lot more to an ROI. There's the whole floor plan. You have to build your floor. And that actually is going to cost more than the equipment if you're a large outfit. Okay? So I want to go next to, so here, this is an ROI for 30 packs per month. Your total gross profit can be large, okay? If you go to 100, you see, if you're selling 100 packs per month, you're going to pay for the equipment in 1.7 months, okay? Now your ROI for the battery is going to be 5.1 months. You got to buy out, if you want to deliver 100 packs per month, at 75%, okay, you're going to move 900 batteries. And in order to do this, you need a highly optimized outfit. So you got to go back and look at that circular structure. And then you need to hire a manufacturing expert to lay out that floor plan. Okay? Nuvant has experts that can lay out floor plans. You can lay out your own floor plan. You can get your own consultant. But the floor plan is going to be very important to minimize non-value added movement, moving things around. You don't want people damaging, hurting their back, lifting, batteries, etc. So at this point, before I go to the questions, I just want to show you just briefly. I'm not going to go over the front panel that much because this really is more relevant to when you have the equipment, how do you actually operate it? We have blower fans that you could use. This is the way you do your inventory. You need to use a QR code reader. You need you want to be careful with how you do your nuts and bolts. So we provide the torque control drill so that you don't over torque and damage the bolts. You need to either refinish the buses altogether, clean them, get them nickel plated, clean them if you want. You can use whatever system you want. And that pretty much concludes the introduction. This is our very first webinar. So I know it was a little rough on the edges. We'll be doing, hopefully, we hope to do more with Car, and we'll improve this as it goes on. But now I'm going to be open for questions. So John, you might want to come over here and help me shift over so that we can go through the chats to start answering questions.
Yep, I'll be right there. 1 second.
Okay. So what I'm going to do now is I'm going to go to, John's going to be here to help me. We're going to go to the chats where people may have input questions. And we can also answer questions or verbally. So John, you want to come in here and oh, let me put my mask on. One second.
Okay. Looks like we don't have any chats.
Okay.
So no. So yeah, we can start. However you want to do it. Yeah, we can
Okay.
have the first
So
person.
but how will we hear it? Okay. So if you notice on your screen, there's a way that you can raise your hand. So if you raise your hand, okay. Thomas has a question. Let's unmute Thomas.
Okay.
Tom, did you have a question?
Can you hear me, guys?
Yes.
Okay, thank you very much for this webinar. I have a question. If I'm not mistaken, at some point you have talked about the possibility of making a selection of the batteries by weighting them. Can you develop a bit this?
Actually, that's part of our system, but the idea behind that is that if a battery is overheated, right, it's going to vent.
No, not the heat, the weight.
Yeah, and that's what I'm explaining.
Okay,
So
sorry.
when a battery is overheated, it's going to vent.
Mm-hmm.
And when it vents, the oxygen that it's actually venting has water vapor in it. So when it vents, the weight of the module is going to decrease. Now, another way, and a more important way, is sometimes the enclosure of the module itself. This particularly happens with the prismatic modules, that they can, the enclosure of the module itself can be breached. For example, if you over torque the nut on the bolt of the battery, you can create a leak where liquid electrolyte will actually seep out of the battery. Mm-hmm. Now, if you have a high-speed way of weighing these modules, then you can actually use that as a filtering technique, and that will save you time and money. And in fact, when you buy our system, we actually include an indicator that you can use, that you just wipe the battery and you can see if the battery was leaking electrolyte.
How much precision are we talking about here?
you need a very high accurate balance. I think, what was it? It was actually 50 milligrams. You need a 1 kilogram balance with a 50 milligram resolution.
Okay. And
There you
but
go.
in any case, if you're losing electrolytes, I suppose that's you have an indication on the internal resistance of the battery, no?
Oh yeah. I mean, some of these filtering techniques are overlapping techniques, right?
Mm-hmm.
But absolutely, if you're leaking, then your resistance is going to go up. And as a matter of fact, that's why in the EVC30, it monitors that. And at a very early stage, it'll knock modules out just based on internal resistance.
Okay, but okay. And would you do you think that the internal resistance measurement is more accurate, or I mean, you will lose less time by measuring the internal resistance, or would you recommend which techniques would you recommend?
You know, we are, you know, Nuvon has just begun actually building plants, okay?
Mm-hmm.
And we have not established, we've now set up weighing stations. And the only reason why I'm not answering your question is I don't know the answer, okay?
Okay.
It depends on how well, remember what I mentioned about non-value added movement, right?
Mm-hmm.
So it's all about, okay, now you got to weigh every single module, right? So it depends on whether you can automate that or not. So that is a work in progress. And hopefully by our next webinar, we'll have more answers for you.
Okay. Well, thank you very much for your answer.
You're welcome. Okay, okay. Any other, okay, so looks like there's no other, hold on. Looks like there's no other questions, right? No. Okay. Should we unmute them all or to see if, oh, there's a hand, let's see. Carolina Segovia.
All right, go ahead, Carolina. You can unmute yourself.
Carolina, unmute yourself and shoot away.
Okay, so after reconditioning the battery, how long the lifetime is going to be? Because I assume it's not going to be the same as a brand new one, right? Like how's the percentage that it's going to be working as a brand new one?
How long will it last, right? Okay. All right. So please, we have to, someone I know unmuted themselves. Please wait until you're called upon by raising your hand. And we'll also work out a way, if you're not sure of how to raise your hand, we're going to get to you. So Carolina, the answer to your question about lifetime, okay, is that Nuvon is not the most reliable source of information for a lifetime because Nuvon is transitioning, right? We've been selling equipment to end users, and these end users have been selling modules. Now Nuvon is moving into the stage of floor plan development, and this issue of lifetime is very relevant. But we ourselves have not sold enough batteries to provide you with that response. However, that information is available. Let me explain how. If you go to the Nuvon website and you will see a link, you will see a tab called EVC unit location. And that is the unit location map. If you go to that map and scroll down, we list every single person that bought our unit, with the exception of about 3 or 4 that did not want to be listed. And in fact, you can even look like, and you will see, incredibly, successful groups, and their websites are there. And you can actually go to their websites. In other words, we provide the contact information of all the unit holders of EVC30s. You can find them there. You can go to their website and you can look at their warranty management information. Some of them have 5 years, some of them have lifetime warranties, etc. Now, what our experience has been, but this is anecdotal. This is not a scientific response, okay? But I can tell you that we reconditioned batteries 4 or 5 years ago. We started in 2014, and we actually had at one time, we actually were the equipment source for the hybrid battery, which eventually was sold and they don't use our equipment now. Those batteries that we reconditioned there are still operating. To give you another good example, we recondition, and they are the same modules, the battery packs for the hybrid buses in the Niagara Frontier Transit Authority in New York. That bus pack has 240 modules. And John, when did we recondition that?
It was about a year and a half ago.
We reconditioned the Niagara Frontier battery pack, the first one, about a year and a half ago. It was installed a year and a half ago. That bus is still running. So, but this is anecdotal. Those are not scientific answers, right? Because now, I will tell you this, now that we're upscaling our work, we are now beginning to acquire data. So we do have at Northeastern University an artificial intelligence program going where we're acquiring this data to give you better warranty management data. But for now, you can learn a lot about what is possible by going to that tab where we list everyone. And you know, some of the people that we're talking about, they're actually attending this meeting, and I'd love to be able to state their name, but I feel a little reluctant to do that without their permission. But you will see the warranty management on our equipment through those sites. So I hope. So I don't want to just give you unscientific data with insufficient data. For example, that information about the hybrid bus for Niagara Frontier, it's factual, but it's anecdotal. It's not enough statistics. But look at our end users to learn more. Does that help?
Yes, thank you very much. Also, can I make just one more last question, please?
Yes.
For example, the Hyundai Sonata batteries are lithium batteries. I just want to make sure what happens with those batteries. They can also be reconditioned the same as the nickel batteries or not?
Today, our system electronically, okay, our equipment can recondition lithium-ion batteries. However, we don't provide those recipes because our recipes for lithium-ion and reconditioning are very unreliable. Whoops, hold on one second. Okay, in other words, what I'm saying is that we're in the process of developing lithium-ion protocols, but they're not ready yet. So it would be a big mistake to attempt to recondition. But remember one thing I want to emphasize. Reconditioning is different from recharging, okay? Right now, if someone, what vehicle did you mention? I think you mentioned a vehicle.
The Hyundai Sonata.
Yeah, so what you can do is, if somebody's battery, if the Hyundai Sonata battery has self-discharge, right? Hyundai Sonata, if that battery has self-discharge to the point where the voltage is so low that you actually have that the vehicle won't allow you to even turn the car on, you can take that battery in and you can recharge it. Now, and that would be with the EVD40, because the EVD40 can charge the entire battery in series, right? It can, because the EVD40 can charge up to 600 volt, and the Hyundai Sonata is not that high. So you can recharge it. So if the battery hasn't been destroyed, I mean, if the battery somehow they manage to destroy it, then there's nothing the EVD can do for you. But we can recharge it. I want to just tell you where our R&D development is going. And we're actually looking for partners. So if any of you out there are interested in partnerships, okay, I'm talking about R&D partnerships. We believe that any lithium-ion battery, which if you break it open, you'll see pouches. We believe that we can replace those damaged pouches, meaning we believe that the time will come where we will be able to process these batteries for you, and you will also. But the good news is that our equipment is built with such high speed capability, and it is built such that any battery that can be reconditioned, the electronics can handle it. So when I say the EVC30 is capable of reconditioning, that has to be in concert with a recipe has to be developed. So just because the electronics can do it, you still need the recipe, and we don't have a reliable recipe to recondition lithium-ion batteries yet. Okay?
Yes, thank you. Thank you so much.
Okay, now we're looking for any more hands to be raised. John, you want to have a look? Thomas has a question.
Yes, go ahead, Thomas. You can unmute yourself.
Thomas, you may unmute yourself. I see your hand is raised.
Yes, I did. Another question, very quick. Maybe I missed this information. If it's the case, I apologize. But when you do the reconditioning and that you perform the deep charge discharge cycles, what is the cutoff voltage? Is it 6 volts per module, or actually lower than this?
Well, you mean when you're doing deep discharge?
Yes, exactly.
Okay, so let me tell you about something about voltage, okay? There's a difference between an open circuit voltage and a voltage under load, okay? So the point is that when you're discharging a battery and you're measuring, or a module, let's say you're discharging a module, right? It's the voltage that you measure is actually the sum of the cell electrode voltages plus the IR drop. Do you understand what I'm saying?
I do.
So if you wanted to discharge the battery to a state of charge with a cutoff voltage of 6 volt, right? You would have to actually go below that depending upon the magnitude of the current. Let me give you an example, okay? When you take a lithium-ion battery, for example, an A123 battery, and they have a sport group, right? A123, and they put that lithium-ion battery in their Formula One vehicle for a race. When they're operating that vehicle at 200 C, right? That battery is at less than a volt. I'm talking about their lithium-ion battery, which is normally like 3.6 volts per cell. It's way low. Why is it so low? Because you have a huge IR drop. So what I'm trying to say is that the word cutoff voltage by itself, it's oversimplified by everyone. Toyota, like 6 volt cutoff only means something at 3.25 amp. You see what I'm getting at? Because at 3.25 amp, the cutoff is 6 volt. That is the cutoff. That is the answer to your question, right? That if you're going to do an analysis in order to rate the battery, then we would do it at 3.25 amp with a 6 volt cutoff, right? But in reconditioning, if your cutoff voltage is 6 volt, it's not going to work. Because in the reconditioning, you have to take into account that the cutoff voltage is a function of the current at which you're reconditioning. So do not confuse the cutoff voltage for reconditioning charge discharge from the cutoff voltage for state of health parameters. However, the cutoff voltage for state of health parameters can be stated associated to 3.25 amps as 6 volt.
Okay, thank you very much.
Any other questions? We're looking for raised hands. I see
Carolina.
Carolina, your hand is still up. Did you have a question?
Yes, thank you. Sorry about this. When is advisable to, I mean, if a customer asked me, should I change the whole core or should I recondition the battery? I mean, when is advisable or when it's not advisable to recondition the battery?
Okay. In our opinion, right? If a customer comes in, I mean, you can, I mean, here's the problem, right? If a customer comes in and they have a PO8, what's that, PO8?
PO880.
You have PO880 warning or something, replace your battery, okay? Here's what you have to consider. If you take that customer's battery, right? And you will recondition it, right? But there's no, when you recondition it, you might find a bad module, right? So if you find a bad module, you can't just go to your inventory, find a good module and stick it in there. Because that customer's remaining modules, even though they're optimized, they may not be balanced. Let me be more specific. They come in with a PO880, right? So they may, if you actually were to get the state of health, you might see 5.8, 5.7, 5.8, and then well, let me go lower. Let's say 4.9, okay? So you're looking at their modules, 4.9, 4.8, 4.9, 4.6, 4.5 amp hours, right? Now, when you do their reconditioning, there's one there at 2 amp hours, right? So you can't, when you pull that 2 amp hour module out of that customer's pack, right? Now you got to go find a module and put it in there with a similar amp hour capacity. But those modules that remain, even though they're good modules, they're still not balanced. The only way to fully get a balanced system is that you can do it. You can take it, you could look at their mean value, you could go to their inventory, your inventory, find a module with the same amp hour capacity and stick it in that customer's pack, put that pack in the car. That will work. But the variants, right? The block variances won't be optimized because even though they're reconditioned, you may not have the high balance with the low. It may not be fully balanced. So the best way to go is this. First of all, if the customer comes in and you're going to recondition their battery and put it back in their car, now they got to wait 24 hours. It takes 24 hours to take a assembly through a full processing. Customers aren't going to want to wait 24, 48 hours. So when they come in with that pack, you want to take that pack, pull a battery off your inventory that's ready and install it. That customer doesn't wait more than 40 minutes. He's in, battery goes in, you take their core, you recondition it, put the really bad ones for the recycler. The other ones, you're going to put back into the inventory. As a matter of fact, let's go through, and basically you're at that cycle, you see? You're actually in the cycle, okay? So, you asked, when do you actually simply recondition those? If you're a small shop, okay? So if you're a small shop and you want to do like 5-10 batteries a month, okay? Then you're not going to have, an inventory of 1,000 modules, right? Then it makes sense to tell the customer, okay, leave your car, come back in a day. And that would be how you would do it. You would recondition it, reject any bad modules. Then you would pull from your shelf a module with a similar amp hour capacity and install that. That would be the case for a very small business. Any large business, if someone comes in, their light is on, they need a new battery, you either sell them a brand new battery or you sell them a reconditioned battery at a lower price. And either of those will work. So everything works. It depends on how you do your ROI calculation and the size of your company. Does that help?
Yes, thank you, Eugene.
Okay, someone put a,
We have some questions, yeah.
yeah, so now I'm seeing.
I'm going to go ahead and repeat the question. We got a question in the chat. So this question is, when a pack is built with the voltage variance of just 0.07 volts throughout different state of charge, let's say 1 month the variance gets wider and eventually the pack fails. And my initial finding is some modules fail earlier because the life cycle of the battery has reached its limit. Life cycle of the battery. So what you're referring to is mainly just the voltage, right? You're not talking about, so state of charge is different from state of health. Our state of health findings looks at both the watt hour and amp hour and resistance of a battery. So those parameters need to be taken into account when you're building a battery, not just that voltage variance that you're referring to.
Right, if all you're looking at is voltage, right? In other words, you cannot build a balanced pack using voltage. In order to build a balanced pack, the first thing you have to do, if you actually look at the cycle, actually, what can we actually show screen? I want to show you something, okay? Hold on. Actually, let's go to the pack builder. Yeah, this is where we want to be. This is where we want to be, right here.
We're going to share the screen again.
I'm going to share screen. Okay. This is where we want to be. Okay. You cannot balance a battery using voltage. Okay? Because you can have batteries all the same voltage with a large variation in amp hour capacity. So you could have, for example, let's look at the red one, okay, the Prius C, okay? So here, if you were to choose this top, that would be 1.3%. I think it's a little high, okay? But here's the point, right? It's not bad. I mean, we've delivered batteries with greater than 1.3. At Nuvant, we delivered 4% variance batteries. And by some stroke of luck, they're still out there. So I'm just saying it depends on how precise you want to be. But here's the point. You see, when you look at these, you see these, how do I get the pointer? Hold on. Where is it? Is it there?
Yep. Oh, no, sorry.
Oops.
Click next to it.
Hold
It's
on.
hard to see. That one. Yep. And then click laser pointer.
Okay. So what I want to point out is this. The first thing is all the amp hour capacities have to be similar, right? Doesn't matter with the voltage, okay? Here are the voltages, you see? Now, if the amp hour capacities are different, then what happens is that even, let's say at full charge, they're all at the same voltage, right? But if you have an amp hour capacity in there that's low, anomalously low, then what will happen is its voltage will drop faster during the discharge and you'll get an error message. So the first thing you have to do to make a balanced pack is have a tight standard deviation. That's what these numbers on this side are, standard deviations. You need to have a tight amp hour capacity. If you selected these 20 modules, right, you see their voltages are here. Now what you have to do with those voltage is you have to take the highest voltage and the lowest voltage. Then the next high, and they're all out of order. That doesn't mean, they're not in order there, you see? So first you sort and you select by amp hour capacity to get an acceptable variance. Then you pair high, low to build the blocks.
Which the software does.
And the software, all of that is done by the software. So here you see it says, take inventory 647 and 1929. That'll give you this block voltage. So these blocks, right, they're not only balanced by voltage, in other words, their voltage variance is 0.75 millivolts. They're also balanced by amp hour capacity. So if you balance solely by voltage, most of your batteries should fail at an early state. Okay, let's go back to the next one.
And I think we have another question in the chat also.
Oh, simulators. I see the simulator raising his hands. So he does.
Yes, go ahead and unmute first, then we'll get back to the chat questions.
Yeah, let's go to this, to somebody. We see you raising your hand. We want to answer you. Can you unmute yourself? Do you not unmute?
Yeah, unmute already.
Okay, now you're good. Shoot away.
Quick question. How often can the batteries or the module recondition? Say, for instance, I reconditioned a battery 2 years ago and the customer come back and say they have an issue. Is it possible for me to recondition and balance out back all those battery modules?
You can. As a matter of fact, just to let you know, when we reconditioned the bus, those batteries were sitting in a crate for 2 years. Now, one thing I have to tell you is that, you know, that there's a lot of parameters that regarding your batteries that we're not aware of. Okay, that is very difficult to give you a definitive answer. But what we have found is that if you recondition batteries, you can recondition them again. However, if you let those batteries self-discharge to, like, you know, where the whole module itself, the entire module is like at 2 volts, 3 volts, that battery is gone. Okay. Can you mute? Hold on. Is that, maybe that's him speaking there. Hold on one moment. Let me fix this.
No, go ahead.
It was similar. So it also depends on a lot of things. Let me give you an example of something. I recently bought 50, I think it was 50, yeah, I bought 50 packs from someone. And I went and inspected those packs. And those, I measured voltages, right? Like a novice, okay? I measured all the voltages. They were great. They were clean. The QR codes were all sequential. There were no markings. I bought them. And I think our return, what was our return, John, on those?
About 20%.
Our return,
They're cores.
they're cores. Our return on those cores were 20%. That is a disaster. You see what I'm saying? And what happened? Well, those batteries may have been overheated. If they're overheated, they can vent water. So it's very difficult. But what I will say is this, right? When you recondition modules, right? You don't want to, the reconditioning process takes 24 hours. However, our equipment does a preliminary rejection in how much time?
About 2 hours.
In 2 hours. That is to say, we will inject a certain number of amp hours, and we'll pull it out. And depending upon what the inject and pull out is, we can reject modules within 2 hours. But so when you have packs that have been sitting for a couple of years, it's really, I mean, they can be reconditioned. They can be reconditioned successfully. We did that with the bus pack. We've done that with other packs, but we've also done it with packs where we have failed miserably. So when you've had packs that have been sitting a long time, it's hard to answer that. You got to check the voltages. If the voltages are really low, like below 5 volt, what is our cut?
Is it below 7 or below 6.5? Like
If,
open circuit.
if you measure an open circuit voltage and it's below 6.5, we don't go there with those. We don't work with those. So I hope that's useful. So any other questions? Okay, someone is saying Kuma. Okay, let's see. I can go up.
That's a question.
What is the minimum accumulated power? What is the minimum accumulated power? Well, in the module too. Are you? I think what you're asking is the power requirement that your facility needs in order to recondition.
Right. I don't really
I'm
fully
not-
understand that
what is-
question.
What is the minimum accumulated power? In the module. So they're asking what the power is, right? Right. So, well, if you take the if you, that, I guess that's available from the power tester, right? So we can, you know what I'm gonna do is I'm gonna have to answer that. We're gonna have to answer that separately, okay? So we will send you an email, only because I just don't have the number off the top of my head, but you know, that's actually on a typical spec sheet. I will get that number for you and we'll come back to you, okay? So what you may wanna do is, you know, shoot an email to Jill at Enocar. So some questions, if we don't do justice to, please send them to me or to Jill, and we'll get back to you on that, okay? Any other questions?
Okay, if anyone else wants to raise their hand, or it looks like we have.
Oh, I see. I think what they mean is what is the cutoff point in amp hours? Okay, good question. Okay, so I think Vander Raden, if he's not interpreting the question correctly, he's at least posing a very good point.
Yes,
And
yes, that's right.
as a matter of fact, that's an excellent question. In fact, I should have devoted time to that. The answer to this is very surprising. Okay, see, the key to a battery operating is balancing. Okay, in other words, you could actually have a very low amp hour capacity battery, but if it's well balanced, it's going to last. In other words, and sometimes the occasion is you can have cab drivers, right? Or they may have a vehicle, and that vehicle has got, the driver knows this vehicle's got 3 months to live. They don't want to, they got a vehicle that's going to last 3 months. They don't want to put a brand new battery in there, okay? They want, what can they use that will give them high performance in their driving, in their automobile driving? Now, remember, when a hybrid vehicle works, remember what I said, it only uses 10% of the battery capacity, you see? So what that means is that you could have an amp hour capacity, what's the lowest? 3.5 amp hour. So if we have built batteries at 3.5 amp hour, but if they're very well balanced, right? In other words, if it's 3.5 amp hour with a standard deviation of 1%, and you block them properly, you put that battery in a vehicle, that vehicle is going to turn over like a brand new car. And that doesn't mean it's going to last forever, but the point is, the issue is more in balancing. Let me give you an example where a 6 amp hour module is bad. Okay, why would you call a 6 amp hour battery a bad module? Okay, this gets back to what, Carolina, what was your name? This gets back to Carolina's question too. It integrates them. So customer comes in with a battery, a vehicle. You recondition all those batteries, right? And they're all at 4 amp hour, but one of them is at 2.9 amp hour, right? What are you gonna do? Well, just because all of the others are at 4 amp hour, you're not gonna get rid of those, right? What you can do is, and you don't want those in your inventory, right? So you give them options. They can buy a new battery, or you can have them on their way, for a year maybe. So I don't, that was anecdotal for you. But the point is that 4 amp hour partial pack, you do not want to go get a brand new module at 6 amp hour and stick it in there, because that 6 amp hour is going to be blocked with a 4 amp hour battery. It's too high, you're going to get a voltage difference and you're going to get an error code. So here's a situation where you have 4 amp hour battery pack with a 3 amp hour in it. You pull it, you put a brand new module in there, and the battery is going to fail. Okay, but if you keep it balanced and you put a 4 amp hour module in there with those 4 amp hour modules, that battery pack will work. So it all depends on the specific situation with the customer. if the customer's coming in there and they said, I got this car, I don't want to buy a new one, I just need this thing to work for 6 months. Then you work a deal with them, right? But here's the point. If you want, what the cutoff point actually is, depends on how you want to manage your warranty, right? So if you want to say, guess what? You know what? We can fix this battery and you'll be off and the error code will be gone, but you got a 4 amp hour battery there, we're not going to warranty this. So the cutoff point, I guess there's two things I want to say that I want to leave this discussion with. And one is that if you have a balanced pack, the car is going to run. And what that cutoff point needs to be depends on how you want to warranty the management or manage the warranty or even have a warranty. Okay?
I mean, I've got one more kind of statement. Once you get to modules that are 2 amp hour, you probably don't want to use anything below 2 because at that point, something else, you'll have more, there's probably some damage to the module once you get below 2 amp hour.
Right.
So I would say 2 amp hours, you know, the cutoff point that you want to completely disregard that module and recycle it.
Right.
But anything above that, you can use in any type of building.
Right. Yeah, I mean, like for example, we use these Prius batteries for power backup for solar photovoltaics in Puerto Rico, for example. They can be repurposed. Now, do you want to sell a 2 amp hour battery? I doubt it. But if, you know, like I said, it all depends, right? I mean, if somebody says, look, I just need this car to run for a week, you know, you can put a 2 amp, if it's balanced, it will work. Okay, now that's a good question. Can an electrolyte be replaced and is it worthwhile? I'm going to answer that question is yes, it can. It can be replaced. Is it worthwhile? We're in the middle of a program to determine that. But we are, now, one thing I want to say, if the electrolyte is missing because the battery has a breach and the electrolyte was leaking out, then replacing it does you no good. It's worthless. However, if the battery vented because it was overheated and water vapor was expelled and the mass diminished, you can do something about that. But I cannot answer that with sufficient statistics, and I cannot answer that with adequate science to give you a definitive answer. All I can tell you is we are working on that, and that is part of our mass weighing program. The loss of water vapor will actually increase the pH. The loss of water vapor increases the viscosity of the electrolyte. The loss of water vapor increases the internal resistance. Loss of water is devastating. However, we believe it can be fixed, but that is not a topic of discussion in this webinar. I don't want to go there because we don't, you know, I don't want to give you information that isn't extremely reliable. We're working on that. So,
Yep. Any other questions? Please raise your hand if you have a question.
please raise your hand if you have a question.
Or because no one's raised their hand, if you want to unmute, you can unmute yourself.
Yeah, you can, if you're not sure of how to raise your hand, unmute yourself and you can just speak up. Oops, do I hear somebody? Is Gabriel trying to talk?
No.
Okay.
Okay, that looks like that takes care of all the questions.
All right.
Do you want to leave? Yeah. Do you want to leave?
Okay, so what I will do is you can, I think that will, we can close this meeting. I don't think so because they know the name of the company. So thank you very much. Most importantly, I want to thank Jill, who was very helpful.
One thing before you go.
Yes.
I come on the live long before you have start. But the product, I never get the name of the product, and if there's a website available for your product, I can
Well,
go by
the website is, well, first of all, it's Nuvant, NUVANT.com. I think we can type it in the chat for everybody, can't we? Can you
Yeah,
do
that is what I was just about to say. Type
What
it
I'm
in the
going to do
chat.
is and you can also contact Enocar. You can all, because they're the ones that kind of sponsored this meeting. So we're so thankful to them for that. But we've actually put on the chat line the website for our company. So there you go. Okay.
Okay, thanks much.
All right. Thank you. We will close this meeting now.
Okay. Thank you,
Thank you.
Gene.
Thank you.
Thank you.